All right. What's up, guys? All right, so we're talking about decentralizing Bitcoin mining. Bitcoin is a fantastic idea. I don't know if you guys knew this, but Bitcoin is a fantastic idea. It's actually like a combination of a lot of different ideas. We've got proof of work, finite supply, blockchain. But one of them that I think we don't talk about quite enough is a very fantastic idea, and it's essential to Bitcoin, is open source. This was so essential that Satoshi's first ever public announcement of Bitcoin was, I've developed a new open source P2P eCash called Bitcoin. It was in the title, like, of the first ever post. So it's important. It's very unlikely that we would all be here if Satoshi had chosen a different license for Bitcoin. Like, say it was totally proprietary, it was a Microsoft project, we wouldn't be here. There's like 0.0% chance that we would all be here talking about Bitcoin had it been a proprietary license. So it's really important, and it speaks to it being decentralized. Like, open source is the decentralized development model. It's your only real option. Like, rather than having to get a job at a public company to be allowed to work on something, you can just do it. Open source allows it, and it is the only decentralized development method for developing a decentralized network like Bitcoin. Bitcoin mining, pretty important part of Bitcoin. It's very important that Bitcoin mining also be open source, so that it can, so that the people who are securing the network, believe it or not, all of us, all the things we're working on are very important to Bitcoin. Bitcoin mining is extremely important. So that needs to be open source so that it can remain decentralized. I'm here with a bunch of fantastic developers working on decentralized tools that are very important to Bitcoin and specifically Bitcoin miners. So I think that's what we're going to talk about today. So I want to give you guys a chance to talk about the projects that you're working on and maybe, introduce us to what you're doing and why it's important to Bitcoin mining, why it's important to decentralization, and why it's open source. Go ahead.
Hey everybody, I'm Brett. I work with Upstream Data on our software team, and I am sort of the lead developer, maintainer, creator of an open source project called PyASIC. PyASIC is like, think about if you took Foreman's monitoring abilities and you open source them. That's essentially what PyASIC is. It's designed to be a simplistic way for people to build their own monitoring applications for their miners, while keeping everything in one simple API that allows you to do pretty much everything you could want to do with a Bitcoin miner.
I'm Mike Hamilton, formerly CTO and Chief Research Officer for Grid. In terms of the open source, sort of Bitcoin mining infrastructure, I was a chip designer for the first part of my career. So I come from the very low level side. Spent quite a bit of time the last few years on the actual the hardware, the hash boards, control boards, and so hopefully I'll be helping out with Mujina firmware. Hopefully, if Ryan will let me, and helping out with some of the 256 projects. So I've got some time and want to help out.
I'm Simple Steve. I've introduced a project called UTX Oracle, which is an open source, decentralized way of getting the price of Bitcoin directly from your node. This is, I think this has the potential to change a lot of things sort of at the ground floor, because the Bitcoin price is on chain. And I've developed some open source tools that allow you to get it yourself. In terms of the Bitcoin mining community, I think this might be important for things like the hash price index. I believe right now that's a product that you get from Luxor. Luxor on the back end is using some APIs to some exchanges. That right there is using a couple third parties. The price they have, that's a whole different conversation, but I'm pretty convinced that the UTX Oracle price is a better price because it's on chain. There's no paper trading. And I think when we look at the history of Bitcoin prices, I think it's going to be the UTX Oracle price that's going to be like the consensus price. But for the hashing community, I think I haven't built the tool yet, but it shouldn't be too hard for me to integrate in this to something. Like if you're a sovereign miner, you don't want to talk to any outside party to get the price. You want to do everything yourself. You should be able to calculate the hash price index completely on your own. So I think that might be helpful for you guys.
That's fantastic. Brett, I was wondering if you could tell us, like, what do miners even use these APIs for? Like, why would I even want to interact with that?
That's a good question. There's a wide variety of uses that different miners have for different parts of the APIs and different things that they want to accomplish, right? So you think about, we've talked a little bit about off-grid mining. So off-grid miners are going to have to deal with stranded and flared natural gas, and that natural gas is going to be a relatively unstable source of power. And so with that being an unstable source of power, now you want to modulate, okay, how many miners do I have online at any given time? How much power are each of those miners consuming? And so with PyASIC, it makes it really simple to go and modulate the power limits of all your miners or shut a couple of them off in order to kind of deal with power limiting and stuff like that for off-grid. With regards to on-grid stuff, you're also going to need a way to curtail when, say, you're working with ERCOT. They go, hey, your power price here is going to be really, really high for today. We need you to shut down your machines. So you are able to go via software and shut those machines down as opposed to power cycling them manually with, say, a smart PDU or something like that. And then in addition to that, there's also something to be said for like being able to monitor your machines, which PyASIC makes it really simple to do that. Keep an eye on the hash rate, the temperatures, the board statuses, the chips, all that type of stuff, the things that you want as long-term metrics in order to figure out what the state of your farm is and be able to project sort of how you think your farm is going to look for some period of time into the future. So it's just a kind of a collection of different tools for control and data management coming off of those miners. So useful in I think a general just oversight and control aspect. I think is the best way to put that probably.
Yeah. Would you say that the current state of the art, especially on stock firmware, is good, bad, worse?
Nobody wants to hear this story. It's that bad.
Okay.
It's actually embarrassing how poorly designed a lot of the current setups are with regards to like what's on stock firmware. Bitmain stock firmware is by far the worst. But that being said, some of the stuff that I've seen in like even WattsMiner stock firmware is terrible. And even some of the aftermarket firmwares, there's a lot of things missing from those APIs. There's a lot of weird technologies being used that make it difficult to work with. Things like gRPC, which as much as I like brains, I'm not a fan of. Bitmain and their modified CG miner that they took a whole bunch of API functions out of, WattsMiner and their multi-levels of stuff where they've got CG miner at one level and then some thing that's proxying only some of those commands to CG miner, and then they have their own custom API, and then they get rid of part of that and decide to deprecate the thing that helps you identify models as soon as they release a new version. It's just overall lots of really stupid things being designed by mostly stock firmware and miner manufacturers. Hey, I'm nothing if not honest.
Tell us the truth, okay? Mike, you have some experience with running a couple miners. Just a few. Like, is there any usefulness? I mean, do you want to do anything additional with your miners? Is that like even useful for making money as a Bitcoin miner?
Yeah, I mean, absolutely. I mean, there's so many things that could be done with either waste heat or modulation of how much power a miner or collectively a facility consumes, and just with this proprietary closed source firmware ecosystem, you just don't have that level of control that allows you to do those sorts of things. Whether or not that is build a water heater or build a load bank that does dynamic frequency response for a microgrid. Those are things that become very difficult to do when you're using these APIs that Brett's talking about how terrible they are, which is super impressive with the project. And all the different versions of firmware, the different miner models, the API differences, the amount of change tracking, and the problems that we ran into at Grid with trying to upgrade miners here, and then things break, where there's a new authentication. MicroBT's early authentication scheme was awful. Just so many mistakes that they made, and for this goal of keeping us locked in on a 82 terahash machine only running at 82 or 150, pick your number, when each of these systems are capable of running across a wide range of frequencies and voltages and power draws. And so, I understand there's some warranty stuff. That's the only legitimate argument for doing any of this, but that's a solvable problem that they've just chosen to not solve historically. So there's just so many different use cases that, because we don't have that fine-grained control, particularly at the API level, but even at the firmware layer, there's just so many things that could be unlocked. Heat reuse is the big one, but there's all sorts of use cases.
Have you ever run into any problems where something changed about the firmware, out from underneath you, something that you were relying on to run your business?
Yes, there was. Yes, there was. I don't even remember what. It was a proprietary third-party firmware, so it wasn't stock firmware. We did a small upgrade, but even that small upgrade was enough of a chunk that this was in the early days of people that were doing curtailment on fixed schedules for different rate schedules, and we missed a curtailment window. And again, it was a relatively small percentage of miners, but it had this byproduct of, by changing it, the curtailment command basically didn't work through the API. And it turns out what the bug was it was a mistake, and it was very interesting. And so we ended up running over a little bit in the curtailment window, which then has the impact of affecting your power bill for the remainder of the contract. So there can be major, when you run into those sorts of problems, there can be major implications on your future cost when those sorts of things change. So it wasn't a super big impact, which is why we did phased upgrades. But but the reason why we have to do those phased upgrades is because they break shit all the time.
Could you imagine being able to have some control over that firmware, control over the API, would allow you to make more money? Is there some algorithm or special sauce or some fine tuning for your particular mine that you could, if you had the ability to change it, that could help out your operation?
Yeah, absolutely. I think there's all sorts of different ways. Again, for our example, we had fixed curtailment windows, and so you have some period of time leading into it that you want to curtail. But we would have to basically give up large chunks of time so that we could ensure, because we weren't entirely sure it was always going to work, to make sure that we had enough time to go manually pull breakers or
send someone out there to run out and just unplug all the miners, shut off a whole row.
The first 6 months of Grid, we had someone that had to live at the site basically, and at 4 a.m. in the winter months, it was 4 a.m. curtailment window. Someone had to go flip breakers at the site until we figured out the network commands and figured out a way to do that. But we had these chunks of time on the front end and the back end to make sure we don't run into the windows. And if we had more fine-grained control, if we controlled the firmware, we can ramp that down slower, but slower in a shorter window, if that makes sense. So instead of ramping down quickly, which is about all you have the option of doing with stock firmware, and then just having this dead period that you give yourself enough time to recover, you could do it closer to the end, and you could ramp more slowly, because you get heat shocks. If you're pulling breakers, it creates all sorts of hardware problems. You've got rapid thermal contraction and expansion on the cooldown and heat up, and so there's actual time that was not mining that could have been mined. And it's it's a small percentage, but 2%, 3%, 4% adds up real quick.
Yeah, like on the firmware side of things, there's the thing that he's sort of getting at is there's a couple different ways you can shut down a miner. There's a software way you can shut down a miner, and there's a hardware way you can shut down a miner. Shutting a miner down in hardware using a breaker or pulling the plug on it is generally less good for the miner than shutting it down in software. So having the ability to shut down in software is really, really helpful. That being said, also turning the miners on, this is where things also get kind of complicated because a lot of stock firmwares are going to have a 15, 20-minute startup time before they get to full hash rate, whereas most aftermarket firmwares, you're looking at trying to be quite a bit faster than that, anywhere from like 2 to 5 minutes. And so that 10-minute window across 100,000 miners is a lot. That's a lot of money. So it's a lot of money that you're wasting because your firmware isn't making good decisions on how it's starting up the ASIC chips.
That's ridiculous. It's like we can figure out this stuff. Like the only reason why this is difficult to like fix these problems is because we have absolutely no idea how this firmware works, and we have no sort of agency to like make any changes. Right? As far as I understand it, it's an adversarial relationship with the manufacturer to load your own firmware onto these devices. So I wanted to talk about something else. You're talking about curtailing, right? I mean, I think that's a pretty big part of Bitcoin mining, and you're sort of trying to match that energy price with the Bitcoin price, essentially, right? So this is I think where UTX Oracle comes in is that Bitcoin price. Like, where do you get that from? Where's the source of truth for that? And maybe Steve, you can talk about, is there a way that we can sort of crowdsource this?
You mean there's other prices of Bitcoin besides the UTX Oracle?
I don't know.
I think there's only one price. I think there's an established price. Yeah, I think.
I mean, is it crowdsourcing? Are we crowdsourcing the price? Like, is that
absolutely? Yeah. Okay. Yeah. It's kind of the open source price. So every second of every day, somebody makes a Bitcoin transaction for exactly $100. Probably everybody in this room has made a transaction for exactly $100 or $50 or $1,000 or $500. This happens every second. Every time somebody makes a round US dollar Bitcoin transaction, they used a price, right, to know how much Bitcoin you have to send. So maybe you just type it in your wallet app, or maybe you use your calculator app on your phone. Maybe you get a price from exchange. Maybe you negotiate a price. But somehow that price information you're using to make a Bitcoin transaction, if I know that this transaction was for $100, I just divide $100 by how much Bitcoin you sent, and I know what rate you used. And that rate is online. I mean, that rate is on chain. Like I said, I'm getting hundreds of thousands of data points per day. The UTX Oracle algorithm just compiles this information, shows you a daily chart. The price matches perfectly with every exchange price. The price has been on chain the whole time. So yeah, it's the crowdsourcing. Yeah. So to Scott's point, these transactions are made by 100,000 independent people every day. So it's the price from how all these different people think the price is. So yes, the crowdsourced price.
The crowdsourced price.
Yeah.
I think one thing about this that's fantastic, you kind of mentioned this, but maybe we can like reiterate this and really drive this point home, is that price is on my node.
Yeah, it's all right. You guys already have the price.
So UTX Oracle is some open source software that I can run on my node that looks at the like transactions, right? Basically the transactions. Is there a way? This is a really cool visual. Maybe you can describe the visual. Like how can you see this price in the sort of on-chain data? Can you just describe that chart as you showed it to me? It's so cool.
Every time somebody asks me to talk about this, it's so much easier when I have the heat maps. Yeah. So if you envision like a giant heat map of every transaction with Bitcoin amount on the y-axis and time on the x-axis, and you just see the hot pockets of high density transactions, this heat map, you'll see that most transactions in Bitcoin are round US dollar transactions. It's like if you're walking around a city of Bitcoin transactions and there's this giant mountain in the middle of the city that you can't miss, that's the $100 Bitcoin transaction every day. You can't miss it. That's my best attempt to describe the visual.
It's so amazing trying to just describe a chart, but it's like the heat map, like the color of the data point is changing based on how many transactions there are at that exact price, right?
Right. Yeah.
Okay, so these clear lines form, these like higher, different color lines form that follow the Bitcoin price at that tier, like exactly.
It is the Bitcoin price. It doesn't follow the Bitcoin price.
It is the
It
Bitcoin
establishes the Bitcoin price.
It's such a wild thing. When you first showed it to me, it was like blowing my mind. There's lots of applications for why you might want to have the price. I think about with the BitAxe project, there's a lot of motivation to, you've got this cool looking thing on your desk all the time. Like, let's show the Bitcoin price on there. But like, it's not cool to just have this, to have your BitAxe hitting Coinbase like on the regular. That's just like, yo, here I am. I'm a Bitcoin miner. Like every day, here's my IP address. So to be able to run that in a self-sovereign way on my node, so that my BitAxe or my block clock or whatever is only contacting my node, and that's it. I think it speaks to that just that like self-sovereign, self-hosting mindset. It's like I can do this. I don't have to rely on someone else for that. So I think it's one of these tools that is part of it's just like a growing, well, first of all, it's just rad. Like, but it's like you just came up with this. It's an idea. You just published it. You didn't have to ask anyone for permission to do it. Anyone can go and get it and run it, right? I mean, you published the software.
Mm-hmm. Yeah.
What's the website?
It's utxo.pro or utxo.live. But yeah, just utxo.pro will get you there. And yeah, permissionless innovation, man. I mean, I've been in Bitcoin for forever, and just like the fact that anybody can do anything, just write any software you want and just publish it, and just the Wild West. It's so freaking cool, man. And the open source community is like what makes that possible. So yeah, it's awesome.
I mean, I just gotta say, you were talking about the visual. I mean, it's on your shirt.
Oh, yeah.
There we go.
It's right here.
I just looked over and I was like, holy shit, that's the chart.
I'm a walking display. Yes, so these blue dots are like the confirmed price. And then I have this like experimental live stream of the mempool price, which I'm not going to call the confirmed price. The mempool price, everybody's got a different mempool. We don't need to get into that again. But yeah, the mempool price is kind of all over the place. But the confirmed price, that's set in stone, man. That's not changing. Yeah.
That's cool. So I'm curious, Brett, how did you even come up with this idea to make PyAsic? And like, well, who did you ask for permission to do it? But like, why did you even want to do it?
Blatant laziness.
Okay.
So
I started
out monitoring a whole bunch of different upstream data units. I started out like having to go through hundreds and hundreds and hundreds of S9s every single day and like note down in an Excel spreadsheet, like what's the hash rate of these miners? What's the temperature? And then you look for like changes over time and you look and see, okay, do I think this unit is running well? Should I turn the fan up on this unit? Things like that. And so after a little while of doing that, I think it was about a month, I finally got tired of doing that because it's exhausting and annoying. And I was like, okay, how do I automate this? And so I just basically went off, learned a little bit about how to code, started finding these APIs, figuring out, okay, where can I source this hash rate information? Where can I source temperature information? And then I can automatically put it into my spreadsheet so I don't have to do this anymore. And so PyAsic was sort of born out of a necessity to get rid of doing the monotonous task of monitoring a bunch of units, because I knew the more units that we put out there and the more units that we sold to people that I had to keep an eye on, the more annoying this project was going to get. So, laziness.
Do you don't have to like explain it to everyone, but do you think you have in your mind like the ideal API?
I'm trying to build it. I'm trying. I'm working on. So I talked about PyAsic, which is the Python version of this. I'm working on rewriting PyAsic in Rust because that's a real funny meme in the Bitcoin industry.
Boom.
So it's called AsicRS. It's up on my personal GitHub, b-rowan/AsicRS. But I'm working on that And the goal right now that I've sort of been working towards is building a unified data standard for Bitcoin miners. Like, this is the data that I expect to get when I want to monitor my Bitcoin miner. And it's a long list of data, but eventually I want to just have that directly on the miner, and we can get rid of this whole requirement for a man in the middle to actually figure out how do I translate between whatever this miner's doing and translate to what I need to go into my database so I can visualize this.
I know some people that are working on mining firmware. We'd love to have that in there.
We should do it. Yeah, let's make it happen.
Okay. Sorry, what is it? Okay. Yeah. I just wanted to ask Mike. I mean, you've been involved in like the hardware side of Bitcoin mining for a while. I guess a hardware background even before Bitcoin. I feel like open source is like pretty rare in the hardware scene, right? Would you agree with that?
Yeah, absolutely.
Can we do this? Can we make open source hardware? Is this going to work?
Yeah, I think so. I mean, there's definitely hurdles to climb. I think if you think about, it's easy to think about the hardware space in this sort of generic hardware, but you have different components to the hardware, which you know as well as anyone. There's the ASICs, which if you're talking to me and you call the machine an ASIC, I might turn around and walk off. I apologize in advance. The ASIC is the chip.
Yes.
The ASIC is the chip.
Lesson one.
Lesson one. That's your takeaway for the day. I can leave now. And so the problem with the ASICs themselves is it's a huge R&D expense. It's a limited customer set that even can get the attention of the fabs and the foundries to even build these. So the ASICs are sort of the number one blocker in this open source hardware.
You want to test your ASIC chip design? $20 million.
Yeah, exactly. And that doesn't even include the $5 million in tooling and $10 million in staffing and lab equipment. So I think the first great step is Raspberry Pi did it with sort of the open source hardware system, or at least like the designs. And so I think there's definitely more there that is historically been available, and obviously Ember One and there's other sort of open source hardware projects. That the key is that ASIC, because even if that is open source, it's still the amount of capital to take an open source ASIC design and ship it off and have it come back. I think that's always going to be a major problem until there's a paradigm shift somehow in that space.